Hello, and welcome to what is the first of our agrimetrics webinars. My name is Richard Tiffin, and as some of you may know, I've been involved with agrimetrics from its inception. I'm particularly excited to be hosting this webinar as we're now beginning to see the vision that John Crawford and I had for agrimetrics coming to fruition. And we're going to see a small part of that reality today. Whilst some of you will be familiar with agrimetrics, I imagine that many will not. So I hope you don't mind if I say a few words about who we are. We're one of 4 centres of innovation in agriculture, set up initially with government investment, the justification for which is that providing the infrastructure for a fully digitised agri-food system is in a sense a public good. But we are all independent commercial organisations with a mandate to reinvest any surplus in our infrastructure. With that background in mind, and before handing over to my colleague Anna Woodley, there are a few practical matters that I would like to address. Although we originally booked this for an hour, Anna's presentation will run for 15 minutes and we will then allow a maximum of 15 minutes for Q&A. You can ask questions at any time in the chat window at the side of the screen, but please note that these questions will be public. If you would prefer to speak confidentially, please don't hesitate to get in touch after the webinar. Slides and a recording of the webinar will be available, and should you need to, you can pause and resume the live webinar using the controls on screen. Doing so will allow you to resume in as live mode. I'm delighted now to hand over to Anna, who will present the webinar.
Thanks, Richard. Hello and welcome. My name is Anna Woodley and I'm the commercial lead here at Agrimetrics. And my background is in commercial horticulture, plant breeding and genetics, and I've worked in the agri-food sector now for just under 15 years. Predominantly in the farm management system space, with an emphasis on using precision farming data to make on-farm decisions. And I've been now with Agrimetrics for coming up to 2 years. So today we will see how the power of artificial intelligence can provide direct business benefits through improving supply chain efficiency. And the example we're going to explore is the challenge of better predicting the time of harvest in perishable produce. And we'll show you how using the tool we've developed could be worth as much as £6 million a year to one business. Now, we are all cognizant of the fact that in the current circumstances, our food supply chains are vulnerable. And one of the targets of Agrimetrics is to reduce this vulnerability through using data. And the example we're going to talk about today shows how models can make these chains much more predictable, as well as to have a big commercial impact for our customers. Missing a harvest window by a matter of days can cost producers a significant amount of money. And although planting to harvest schedules are planned in great detail, crop maturity is influenced by many factors and the processes which connect them are hugely complex. And this makes harvest forecasting an ideal candidate for the application of artificial intelligence or AI. For some crops at certain times of year, even a few days delay in delivery can have a large impact on the value and the volume of sales. And we might refer to this as the barbecue effect, whereby consumers will buy certain salads and vegetables to have with their barbecues at the weekend, and then the sales figures reflect this. And the volume of produce sold and the value of it will be much higher if it's on the shelves by Friday morning. And if a grower misses this window, the produce is far less sought after the weekend. And the difference in value that this results in is huge. And for one UK leading food and farming business, it's up to £120,000 a week just on one of their produce lines. And as the cost increases as the window shortens, so given enough warning, a supplier might be able to arrange alternative faster shipping. They may be able to change the management of the crop to accelerate its development, or they may be able to find an alternative source. And in situations where multiple sequential croppings occur, accurate prediction of the day of harvest 4 weeks in advance has the potential to make a big difference to an organisation's profitability. Now, the AI that we've developed with our customer predicts whether a crop will be mature for a 7-day shipment window 4 weeks in advance of that window. And this represents a 4-fold increase in what was previously possible. The AI provides decision support, which improves the efficiency of the supply chain and mitigates risk. Different factors affect how rapidly a crop matures. Weather is one of these, but also management actions on farm, crop type, location, topography of the field, previous cropping, and the date of planting. So, how have we created our AI against this backdrop of factors? The agrimetrics data scientists identified the key elements and brought these together into a model that could accurately predict harvest date. And we did this by coupling together 2 models, a crop model and a weather forecast, to create a harvest prediction model. For the crop model, the grower provided data for approximately 100 different fields across 3 farm locations. And this data comprised of planting and harvest dates for all of the crops in the target fields and weather observation data. And using this data, we were able to train models to simulate the growth of the crop based on weather, planting and harvest dates. And different models were trained at different locations to capture the site-specific features that will influence crop maturity. Now, for the actual simulation, we use forecast weather to drive the model to produce a prediction of harvest date. And we had to develop our own weather forecast because none of the products available elsewhere provide the requisite level of granularity that was required. Now, in other geographies, this may well not be the case. So our weather forecast combines a long-term average of weather conditions across multiple growing seasons with a short-term predictor, which uses the recent past as a guideline to what will happen in the future. And in common with most modelers, one of the challenges we faced was the need to obtain data from multiple sources to test, validate, and then improve our model. And this task often represents one of the most significant time costs in developing artificial intelligence. And our vision is that as the agrimetrics data marketplace grows, the challenges of finding and connecting data will be reduced for everyone. To test a model, it's important to use different data to the data used to create it. And this ensures that the model will perform when it's being used for live predictions. Now, accuracy in this particular case was defined as correctly predicting that the harvest date was within the shipment window 4 weeks in advance. And in the farm that provided the most source data, the accuracy of our prediction model was at 92%. And on the farm with the least amount of training data, this fell to 63%. But overall, across all of the farms, the harvest prediction accuracy was at 81%. And prior to using this model, the grower was only able to forecast up to 1 week in advance of the shipping window. Using our model, they're able to predict up to 4 weeks in advance whether the harvest time would meet the correct shipping window. And this equates to a 300% improvement. And any amount of advanced warning of a failure to meet the harvest window will provide benefits, be they through an ability to source alternative product or to rearrange transport so that the shipping speed is improved. So it is all a matter of time, and using our model means that the producer has 4 times longer to deal with the consequences of missing the harvest window, which is 4 times longer to get ahead of the competition. So this does make a big difference, and our estimates suggest that for a typical producer, this could translate into a £6 million saving per year, which could represent as much as a 15% increase in gross profit. So that is what makes this technology so exciting, and we know that the margins in fresh produce are incredibly tight, so we really want to help our customers achieve similar savings. But that's not all. Using the model contributes to greater sustainability through reduced waste and reduced inputs. It improves relationships between suppliers and customers because they know that the predictions can be relied upon, and there will be cost savings beyond the immediate impacts on predicting product availability. Given the access to relevant data, our AI can be adapted to forecast the harvest dates of any crop at any location and for any supply chain. And we are here to help with your data-related challenges, and together we really believe we can achieve a great deal. So I'd like to thank you all for taking the time to join us for this short session today. We are here to do business with you, and we do lots of really exciting things. So please do get in touch or drop a note into the Q&A chat box if any of what we've discussed has fired your imagination, or you'd like to understand more about agrimetrics solutions and services.